So hello everybody, and in this video I will share my solutions to the Google CodeJam 2021 qualification round. So I was able to solve the first four problems, and I did try the last problem but I was not able to solve that. So I will go over the first four problems and try to explain them uh, as much as I can. So let's start with the first problem. So the first problem is quite an easy one. It's like more on the implementation side. So let's get started. So the first problem says the first problem defines an algorithm called the reverse sort algorithm. So it is not actually an algorithm, but they have like made an algorithm up for the question. So the algorithm says that if you're given an array a1, a2, a3, and please excuse my drawing because I'm using a mouse, up to an. So what you can do is you want to sort this array, and to sort this you do n minus 1 iterations. In the first iteration you start at the first index and go up to an index to find the minimum element. If you find the minimum element, let's say at this index, you will reverse this whole array and the minimum element will now be at the first index. And the cost to reverse this is the length of the subarray that you are reversing. So the cost is equal to length of the subarray. So if you are reversing a subarray of from index ai to aj, the cost will be j minus I plus 1. So the first question asks you to like you are given an array and you have to calculate the cost. Let me show you. So you are given a permutation and you have to calculate the cost of the permutation. But the good thing is n is equal to 100, and but the good thing is n is equal to 100 and t is equal to 100. So what you can do is you can do a brute force approach. You can run n minus 1 iterations, find the minimum element, and as it is a permutation, you already know the element you need. Like if it is a permutation, you always need a 1 here in the first position. So you just go over the whole array and look for a 1, and then just reverse the whole array, and then just reverse the whole array. Reversing will take O of n, and there are n minus 1 iterations. So the whole algorithm will be O of n square. So for n square, this will be equal to 10 to the power 4, and you have 10 to the power 2 cases. So total complexity will be t into n square. This will be 10 to the power 6, which can be easily run in 1 second. So you can just do the brute force method here. So let me show you my code. So I just do the n minus 1 iterations here, do the n minus 1 iterations. And then for every iteration I go over the right of the I go to the right of the element and look for the element I need here. At the first position I need 1, at the second position I need 2, so I just look for the value I plus 1, and then I just add to the cost the value j minus I plus 1 and reverse the array. This is a STL function, reverse, so you can look it up. Then I just reverse the array and that is it. Then I just print the cost. Rest is my template. So that was it for this problem. Also the third problem was connected to this problem, so I will cover that first. So the third problem is reverse sort engineering. So in this problem what you are given is you are given the cost here. So from the cost you have to now make up the permutation. Like first you had the permutation and you had to get the cost, but now you have the cost and you need to get the permutation that will make that specific cost. There can be multiple answers, you need to print any. Let's see how to approach this problem. So first of all, what can be the minimum cost of a permutation? So the minimum cost will be when all the elements are sorted. So if we have 1 2 3 and up to this to n, so for every n minus 1 iteration you will reverse array sub array of length 1. So for every element the cost will be 1. The minimum cost will be n minus 1 here. Okay, also we see a very interesting thing here, like for every element you always use at least one cost. Like there cannot be a zero cost for any element, so this will be very helpful in the later stage. So just remember that if you are at a iteration you always need to use one cost, you can never use a zero cost. So the minimum cost will be n minus 1, because for 1 2 3 to n minus 1 iterations you will use a cost of 1. Now when will we get the maximum cost? Maximum cost will be when we will have to reverse the subarray of maximum length for every element. So let's say for the first element we find 1 at position n, and so we have to reverse the whole subarray of length n, so the cost will be equal to n. Then 1 will come here. Then just assume after this swap somehow 2 also came to the last position. Then for 2 we will have to use a subarray of length n minus 1. Then 2 will be here, and let's assume after these two swaps somehow 3 came here. So now the cost will be n minus 2. And this is similarly we can check for 4. This will be n minus 3 up to the last element here. This will be n and this will be n minus 1. Then we can just swap again using a cost of 2. So the last cost will be 2. So the maximum cost here should be n into n plus 1 by 2. And we can just add 1 here and subtract 1. This will be the sum of first n and n natural numbers. So this will be n into n plus 1 by 2 minus 1. So this is the max cost. So we get a range now. We get a range from n minus 1 to n into n plus 1 over 2 minus 1. So if the cost is less than n minus 1, then the answer will be impossible. And if the cost is greater than this, then the answer will again be impossible. So now we have made out a range, like the cost will always lie in this range. So now let's start how to implement this and figure out the permutation. So let's keep track of the index. Like when we reverse, the index will get interchanged and stuff. So we need to keep track like which index is where add after an operation. So just keep an index array. Let's keep array index. This will contain the index for 0 1 2 3 and n minus 1. Now before any operation, index 0 will be in the 0th position, index 1 will be in the first position, and so on. So let's start doing operations now. Now we know like we have a cost here that we need to achieve. So let's start with the first element. Now we know that we have a cost to achieve, and we know that we are also left with n minus 2 iterations to go. We have n minus 2 iterations to go, and then here will be the last element. So we need to use some cost, like we need to use something here. Let's say we use this, call this use cost. And if we use a cost too great and the leftover cost becomes less than n minus 2, then we will not be able to fit the required permutation in here, because for every element, like I said, for every element you need at least a cost of 1. But if cost is less than n minus 2, then we will not be able to do n minus 2 operations for the elements that are left over. So one of the very first operation we need here is that after using a cost here, the leftover cost should always be greater than or equal to, and if we are at index I here, then this should be n minus 2 minus I, because if the cost is less than this, then we will not be able to use the cost for the leftover elements. So the cost should be greater than or equal to n minus 2 minus I after using this cost. So we can find this cost. So we know that cost minus use cost should be greater than or equal to n minus 2 minus I. So we can use cost minus n minus 2 minus I, and we can just shift the use cost over this side. So this should be use cost should be less than or equal to this. So we will get a value from here, like the maximum cost. We'll get the maximum use cost that we can use, because this is less than equal to. We will get a maximum value from here. Let's say we get a value x. Now we are at position I. So the maximum subarray that we can reverse is of length n minus I. So we also need to keep this in mind. So like if you are at a, let's say, index 5, then you cannot reverse a subarray of length n, because you have already traversed 5 index ahead. So if, like, let's say use cost is equal to n, then you will not be able to use the full cost n, because now you do not have n operation, because the leftover subarray does not have enough length to do a reversal of length n. So here we will find a bound, like we need to find the cost. The maximum cost we can use is use cost. This is the maximum cost that we can use, but also at index I, the maximum possible cost is n minus I. So we just find the minimum of this, like if we can use n minus 1 n minus I and use cost, because this is the maximum cost that we can use, but this is the maximum possible cost that we can use. So if use cost is greater than n minus I, then we can use n minus I at most, so we do this. But if n minus I is greater than use cost, then we have to use the use cost, because if we use greater than use cost, then we will run into this dilemma that we will not have enough subarrays left to use a cost of 1. So that is it. Now for every index, you can just go on and find this use cost, and when you find this use cost, you can just reverse the subarray, and after reversing the subarray, you will reverse the index subarray. So we know the indexes. So just reverse from I to I plus use cost. Okay, like not use cost, but here use cost should be equal to, you can change the use cost is equal to a minimum of n minus I and use cost. So this is very important. So I plus use cost. After this, the index will get reversed and you will get 4 3 2 1 0 5 6, and now index 4 is at this position. So now you know that index 4 has to be 1, because this is position 1 and you have sorted, and now 4 is here, so index 4 should be equal to 1. So you can use answer of 4 is equal to 1, or in iteration formula you can write answer of v of I should be equal to I plus 1, and just keep on doing this for the whole array, and you will find the permutation. I hope I did not overcomplicate things and I was able to deliver the idea. So let me show you my code. Yep, this is it. So here I have the left, like the cost, the leftover cost. So this is the leftover cost. This thing that I need to, that I at least need to have after I do this operation. And the maximum here, the maximum cost I can use here is equal to this. And the cost I'm using here is the maximum permissible cost, like the maximum cost I can use here, and the cost minus left, like let me show you, and the cost minus left, this cost minus n minus 2 minus I. So this was cost minus left, this is cost minus left. So I'm basically minimizing this. I apply this here, I'm minimizing n minus I and cost minus left. This is just mathematics. So I assume you guys can figure it out on your own. Just have a notebook and have a pencil and just keep on writing down and scribbling, and you will find out the formula in the end. And then just reduce it from the cost, then reverse the subarray, and answer of v of I is equal to I plus 1. And very important, in the end, in the nth iteration, the index that will be at the last position will be equal to n. So this is important. So that because this index will never be used, so you need to mark it n manually at the end. This was it, and you will get the permutation in the end. And that was it for problem B. Sorry, problem C. So now let's go to problem B. So in problem B you are given, let me close this. So in problem B you are given an array of three elements, not an array, a string of 3 elements, namely C, J and question mark. And but CJ and JC have copyrighted their trademarks. So every time CJ and JC appear consecutively, like CJ appears in the array in the string and JC appears in the string, they will take some amount of money from you. Okay, so your task is to minimize the money you give to them. And there is a hidden verdict where the cost is negative, meaning for every time their name appears, they will give money to you. So you need to maximize the money you have. You need to maximize the money you have, or you want to minimize the money that you give out. So that is basically the idea of the problem. So let's say you have an array, a string of characters, some characters. This is a when you see maximize or minimize, and you have some like transition states from C to J, from J to C, you should immediately think of DP. So I use DP in this solution. So for every position, so let's say this position, I calculated DP of I, of 0 and of 1. What this means is I calculate the maximum money that I will have up to ith position if the ith character is C, or if the ith character is J. So you can just start from the first position. If first position is C, you can just mark DP of 0. Sorry, I draw with the mouse, so that's why my drawing is very bad. So you get DP of 0, 0 equal to 0, because the first character is C and the money we lose here is 0. If this character is J, then you do DP of 0 and DP of 1 is equal to 0. So, and if this character is a question mark, then you initialize both of them as 0, and then you go on to transitions. So there are 3 possible transitions. First we have a C. So you are transferring from C to the current character, you are transferring from J to the current character, or you are transferring from question mark to a current character. So if it is a C, we do not care about dp of I1 because this character will never be a J. So we don't consider the possibility of dpij. So we don't consider we don't consider the possibility of dpi1. So we just ignore this and just transition from dpi of 0 dpi0. So if current character is C, we lose nothing. So dp of I plus 1 0 is equal to dp of I0. But if current character is a J, we lose some money. So we just add dp of I plus 1 J if this is a J. So add some cost, whatever the cost is, to this thing. Similarly for J, we don't consider the case when the ith character, when the previous character we are transferring from is J, we don't consider the possibility of it being C. So we disregard dp of I0. We don't consider this thing, and then we just do the same transitions for J like we had for C. And for question mark, we consider the possibilities of both dpi0 and of dpi1. So basically we combine both of these cases and add it to the third case and just add all the four transitions. So this was it, and we need to minimize the cost. So you can see here, this is a map I used to map C to 0 and to J to 1. If s of 0 is equal to C or s of 0 is equal to J, I did dp of 0 and added the corresponding character to 0. But if it is a question mark, I initialize both of them as 0. Then for all the characters are iterated over, and if the last character is C, I disregard it being a J. So you can see I use dp of I minus 1 0, dp of I minus 1 0. So I don't use the dp I minus 1 state because I know the last character is C. It will never be J because it is fixed. It will never be J, so I don't need to consider the case when it is J. So I think about that, and I just do a transition from dp of I minus 1 0 to dp of I0 and dp of I minus 1 0 to dp of I1. That is, the last character was C and this is also a C, and the last character was C and this is a J. And then if last character is J, I do the same thing I had in C. And if last character is a J and the current character is a C, I add some cost here. But if last character is a J and this character is also a J, I don't need to add any cost. And if last character was ambiguous, like it was a question mark, so it can be C also, it can be J also. So I consider both the cases, the case of C and the case of J. So if last character was a C and this is a C, I add no cost. If the last character was a C and this is a J, then I need to add the cost X. If the last character was J and this is a C, I add cost Y. If the last character was J and this is also a J, I don't need to add any cost. Okay, so now we get to the endpoint. If the last character is a C or it is a J, then I need to print the cost corresponding to that character. Otherwise, if it is a question mark, I need to find the minimum cost among it being a C or it being a J. So I just print minimum of them both. So this is a standard DP problem. I think everybody can solve this. Like if you have done DP, you can easily think of this, a standard DP problem. So video is over 24 minutes, so let me wrap this up really quick. I don't want this to be a very large video. So I explained the first three problems. Let's move to the fourth problem. The fourth one is an interactive problem, and if you have ever done interactive problems on code forces, you will know most of them usually revolve around the idea of binary search. Interactive problem. So what you are given is You the judge has hidden a oh, this the judge has hidden a permutation of length n, and in each query you can ask about about three values like 1 2 3, and it will tell you which value is the median, and you need to like form the sequence from these queries. Like you can ask some fixed amount of queries, and after these queries you need to print out the sequence in either in either the same manner as the judge has thought of it as, or in the reversed manner. So like this is also an answer, and you can also print this in the reverse order, because you cannot guess the order of the elements. You can just uh, you can guess their relative position, but you cannot guess the order, like it is in ascending or descending, like you can think of it as that way. So it is ascending or descending from these queries, so you can only guess the order, like which two elements are together, which two elements are not together. So you need to print either of these arrays, like in the straight manner, or in the reverse manner. If you do interactive problems on CodeChef or on Codeforces, you need know that binary search is many times a very close algorithm that is used on interactive problems. So my idea for this problem was, we can see the queries here. For n equal to 50, we are only getting 170 queries. So if I do the math here, 170 over 50, so that is about 3.4 query. Like you need to find the position of an element in about 4 queries, like let's say, and log of 2. If we find log 2 of 50, so it is 5.64. So binary search on average will take around 6 queries. So I was very like, I knew that this will somehow fail the hidden test case. Like this could have worked on the first two test cases, but I wanted to like get the full score. So I went with turn research. So turn research has a factor of log 3 of 50. It is multiplying, so let me just use a trick here. Log of 10 over log of 3. So it is about 3.5. So it is in the ballpark that we are looking for. So this should work. Also, the first two elements we can just place them. We can place the first two elements as we like. So we can also subtract the queries for the first two elements. So like you can get the idea. We need to use ternary search here, or you can use binary search if you optimize it well enough. I don't know, but I went with ternary search. So my idea is I placed two elements 1 and 2 just before doing any query, and then what I did was I break this element into two sections. First one was low and first one was high, and then I asked if my current element, then I queried 1 2 and the element that I want to insert. Let's say the element I want to insert at this moment is, I have already inserted, let's say 3 4 5. Now I want to insert 6. Now I want to insert 7. So I ask low or high. I get the elements at this position and at this position. Let's say element at this position was 4 and the element at this position was 3. So I ask about the median of 3 7 and 4. So if the judge says the median is 7, then I know that the 7 lies between these 2 points. So I just then mark this as the starting point, mark this as the ending point, and again start searching on the like uh, this subarray. And if the judge says no, 4 is the median, so I know 7 lies to this side, so I can just mark this point then as the start, this point as the end, and then do similar turn research. And if it says no, 3 is the median, then I know 7 lies to this side, then I can just mark this as start, mark this boundary as an end, and then start turn research here again. So I can just go on doing turn research. A very important edge case to remember is like when the element is a corner, like if the element is 3 here, your turn research will go on and on, it will finally collapse here. So if it collapses, you know that yeah, my element lies to the corner, so you need to place it here. So you just place it here, otherwise you will always find some index where you can place it. So just insert it, and n is like 50, so you can insert easily into a vector, because inserting into a vector is O of n, and there are like there are 10 to the power 4 queries about, so you can use 10 to the power 4 into 50, so 10 to the power, let's assume 6, so this should work. So just go on turn research, and whenever rest is just implementation, the idea is turn research, you need to turn research over the array. So just look, if the median lies in this, just mark this as start, mark this as end, and again do the search. If you get like this element is the median, then we know element lies here, then mark this as the end, mark this side as the start, and again do the turn research similarly for this side, and just look out for infinite loops. So just don't fall into infinite loops, and just care about the edge cases. Like you don't fall into edge cases, like if the element lies on the corner, just cover that case and try to optimize your turn research, because still it has some room that it can use more searches. So just try to optimize your turn research. And so that was it for this problem. So I use an assert here, because if I exceed the required queries, it will just send out a runtime error. This is, I place the first element at the second element, then I start placing elements from 3 to n. Start is 0, end is I minus 2. This is the turn research, this is my low point, this is my high point, and these are just some optimizations. Like this is my turn research was falling into an infinite loop. Like if my subarray had length of 2, then my turn research was falling into an infinite loop. So to cover this case, I had to place an extra if condition here. So depends on it depends on your implementation, how you are implementing this. So just look out for infinite loops. And this one is to optimize my it is to optimize my turn research. Like if I find interval of length 1, then I know that my and none of these are the corners, then I know that my element will be the median here. Then I don't need to search, I can directly place my element here, so I don't waste a search here. If the length of this block is 1, so I don't waste a search here. I can directly place my element here, knowing that this is not the 0th index, and this is not the last index, which is I minus 2 index, and I can directly place my element here, because I know like it will always lie between these two, because this is a block of length 1, and I somehow came to this block, so the element must lie in this block. So this was the optimization. Like it can save you 1 query per element, so like 40 to 50 queries, so that is a lot of queries. So it was quite optimization, because before this optimization, I remember I was failing the hidden test case, and after I added this optimization, my code passed the hidden. Like I ran this on my local computer and it passed the hidden test case according to my computer. And rest are just implementation. If query is I know it lies in the middle segment. So if query is I set the lower index to start and I set the higher index to high. And if the query's answer of low, like if my element lies to the left, then I use low equal to end, like I define the end boundary to be left. And this is start equal to end and start is equal to 0. This is the case that covers the edge case, like when my element lies on the border. So this element, if start is equal to end, like if my ternary search has collapsed and it has 0 length and I have collapsed at the left side, then my element lies on the left corner. And if my ternary search collapses at the right side, then it lies on the right hand border. So I just insert the element there. If this is not the case, just mark start equal to high, like just this is my high. And if my element lies on the right side, just mark this is equal to start, this is already my ends, and just keep on doing the turn research here. And then just resize n. It is important to resize because if you are inserting elements, it will soon start to overflow, not overflow, like it will have 2n elements after insertion. 2n, not like 2n minus 2 elements. Well, whatever the case, because I am defining a size here of n, you can define here a size of 2. That should also work, but whatever. So uh, this is just implementation based, like it depends on how you implement that. And then just print the array and then take an input. This is very important, because sometimes you don't take the input. So after you output, you need to take the input and check if it is equal to 1, like your answer is correct, so you can return true and start with the next test case. Otherwise it must have returned -1, so your answer is wrong, so you just need to exit so you can receive the wrong answer verdict. Otherwise you can receive the TLE verdict or some other verdict. Like it can really mess up. You'll be thinking like your answer is doing TLE, but it was just giving out wrong answer. So like it is very important to have important to read the input output, the format of the judge, and just make a solution so that it works fluently with that. Because if you don't read this here, you will just keep on outputting and the judge will not respond with anything. You will just keep on waiting here for the input and it will just TLE out, and you will think, yeah, my solution is giving out TLE, I need to optimize it. But the only problem was you were printing out wrong answer. Yeah, so that was it. This was my solution to the first 4 problems, and if you guys have any doubt, let me know and I will try to help you. Also, if you guys want to talk or do something, just text me on Discord. I will add my Discord down below. And if you guys need any help with Sublime Text or something, or you guys just want to chat, that I am always up for that. So yeah, that was it. And I hope you guys have a good day and good luck for the next round, whoever so qualified. I hope you qualified because the first 3 problems were quite easy. I think everybody must have qualified. So yeah, good luck everybody, and hope you see, and I hope I see you in the next round. Bye bye.